Welcome to Physics 2210 again. I'm Christian Tapiro, and I'm going to correct some of the problems from exam 3. In this case, one of the multiple choice questions was this one, actually it's number 3. Stated a skateboarder travels down a curved path. So basically, a skateboarder is traveling down. So he starts here. I guess this is my skateboarder. And ending up at a lower height than where he started. So he was his initial position. And his final position is this one. And which statement is correct about the work on the skateboarder by the normal force and by the force of gravity? So what this question is asking is basically that what's the work that the normal force and the force of gravity are doing in the skater. Well, we know that in this case work is force times the dot product of distance, and as such, because this is a vector, it's also multiplied by the cosine of the angle of such force and such distance. In this case, because the normal force that is acting on the skater is 90 degrees from the distance, the distance basically is going roughly that way, the normal force is doing an angle of 90 degrees, and because of that the normal force is not doing any work, no work. So normal force is equal the work, actually write down that again. Work in normal force is 0 because the angle is 90. And now, what type of work is the gravity doing on the skateboarder? I answered that it was doing a negative work because I thought, since it's going down negative, I was like thinking on the analogy about throwing the ball up, and how like the gravity or the acceleration of gravity is always doing like going negative for some reason, and I got confused. But in this problem it's different. We see, we understand this relationship. We understand that in this case gravity is doing a work, well, acting on the body like that, and because the displacement that is going, this moment that this skater is doing is comes from a positive to 0, means that the displacement somehow is going down basically, and for such the angle that the displacement and the force of gravity have is 0, and that's why the work done by gravity is equal in this case, I meant to say, is positive. So our is positive in this case. If for example, if the skater went from this point to a higher point, then the gravity will be negative because it really does. Okay, moving on. In the exam, we got this problem. This was actually a really interesting problem, and I think I wasn't expecting this on an exam. It's really interesting because there's 0.0 0.60 kilogram tennis ball, mass of the tennis ball, is moving with a speed of 4.5 meters per second. So the velocity initial is 4.5 meters per second. And it says, and another ball with a like mass 2, and actually I'm gonna change this to mass 1. Small, it has a 0.090 kilograms of mass and an initial speed of 3 meters per second. Now, I was really like abrumed, or like really caught up with time, because I was like, oh, I need to solve this with basically linear momentum, which is like basically a initial momentum is equal to a final momentum, and you can solve this problem. Well, I forgot to say that this basically these two billiard balls or tennis balls are going to collide in some point of time, and they want us to determine the speed and the direction of the both balls at the end, you know. So I was like, okay, well, you can basically find this, and we're gonna have like a mass, and then we're gonna have two masses. Well, one, 2 plus 2 equals 2. This is the initial values. Well, the mass is the same. V is final in this case, and blah blah blah. But I found out that there's a then you need to transform this to kinetic energy to solve for V, and it's kind of bulky. It's gonna complicate things if you do it that way. So what you want to do is, well, understand the problem first. Like, for example, both balls are moving on the same direction, but this one is going 2.4 meters per second, and this one is going slower. So in some point, they're gonna meet in some point, and that's the key to solve this problem, because in the point when they meet, at the time they meet, this ball, I don't know if I can explain it correctly or clear, but this first ball A, is going with this speed of 44.5 meters per second. This ball is gonna reach this other one, and when it reaches, it's going to have some velocity, and this one too. But in this case, it's true also that this ball is going 1.5 meters per second. We can say that because it's the same. I'm gonna make a relationship here. This ball, we can say, is going 1.5 meters per second. And we actually, because at some point when they collide, this ball, we look at that very exact time frame, we're gonna find out that this ball was basically being on a stop or complete rest. So we can say that this ball was going 1.5 meters per second, and this one was going it was at rest at some point that we really don't care. We can actually calculate that, but that's not the purpose of this video and or this question. And then if we have this, we have the special case of elastic collisions, where if this ball is at rest and this one has certain velocity, and both is a perfect collision, that means that this ball is going to kick and bounce perfectly. Then we can plug in this formula right here. Let me show you this formula that describes this one right here, that describes the movement. Well, you can plug in this formula and you can get the velocity prime 1 and velocity prime 2. And that's what you have to use to solve for both. And then you get, if you plug the numbers in, you'll get that basically prime 1 was 2.5 meters per second and 2 is 4.2 meters per second. Okay, and that's with that problem. The next problem that I got basically need to correct was about a collision, a coconut collision or explosion basically. Since a coconut has a velocity of 3.0 meters per, just gonna put here 9 per second east, so it's going this way. And a firecracker in the coconut blows the coconut into 3 pieces. 2 pieces of equal fly off of the south and west perpendicular to each other, so basically one of them fly out this way, and they want us to know this one has bigger mass, twice the mass of these two, and what is the speed? What is this speed? The speed of the third piece of coconut. And what you need to do is basically apply some mathematics here. 4m, sum the masses, then create the momentum for, and because this is basically kind of like a problem in 3 dimensions, not in 3 dimensions but like 2 dimensions, you need to include the dimensions you're dealing with. And basically you need to include all of those dimensions, and you get that the velocity is equal to 18.9 meters per second, and that is going 32 degrees north of east. Yeah, that's what I got wrong. I basically could use Connecticut on that, but basically that easy. And I think that's it. Thank you so much for watching this video, and I hope you enjoy it. Bye.